Hi, welcome back to the Earth Science Classroom. We're in the plate tectonics playlist, looking at Lake Baikal, looking at the formation geology. So pretty much this video is looking at, basically geologically what is the lake geologically, in terms of the basement rock, in terms of the volcanism, or a small amount, looking at the types or theories or models in which we try and explain the formation of this amazingly deep and very old lake, and looking at the surrounding history, which will give clues to its current conditions and perhaps where this area might go geologically and tectonically in the future. Is it going to be a new ocean? Is it going to be just a single rift system and basins and depressions, and it'll stay kind of the same thing? Or will it be a new kind of microplate created in a small inland ocean? So, guys, welcome to the video, and join me now. All right, so this is part 2 video. I'll give a little shout out to part 1. Part 1 was on the tectonics and location. So if we're looking at this map, and I've kind of like drawn it with these tectonic zones and areas and plates. Lake Baikal is right here. There we go. And this orange color is showing you that there is a divergent area, a rift valley, a depression, kind of this area here, this kind of like rift valley zones. We call this the Baikal Rift Zone, or BRZ short. And it's in basically Northeast Asia. It's on the Eurasian plate. There is smaller microplates that are around it. You've got the Eurasian plate right here, and you also have a small microplate called the Amur or the Amurian plate right there, which is kind of like in this location right here. And the Yangtze plate down here, the Chinese plate down here. Now we have obviously the reason why Lake Baikal is so interesting for geologists is not just because it's deep, right? So it's insanely deep. It's over a mile deep. It is over 5,387 feet at its deepest point. Now that's not the whole lake. That's kind of like in the central basin. There's a middle basin. There's 3 basins, and the deepest one is the middle one. So a mile is 5,280 feet, and it's deeper than a mile, and it's a pretty large lake. It's 395 miles in length and nearly 50 miles. It's like 49.7 miles wide. So you have this pretty large, very lake, kind of long, elongated, kind of like a horseshoe type, crescent moon type shape to it. But it's amazing because it's not really close to any kind of active tectonic boundary. You see here where the Himalayas are right here. You have this, the Indian subcontinent or the Indo-Australian plate is pushing this way, has done for the last 70 million years as it made its way up through the ancient Tetras Sea and made collision with Eurasian plate, and that caused the Persian, Tibetan, Burma orogeny. Oh, there we go, orogeny. And then you have also this very stable Siberian Craton. Siberian, wow, I can't spell Siberian. Siberian. All right. And this Craton dates back to Precambrian years, so as old as 3.2 billion years ago. So you've got this very ancient, very large major plate with Eurasian, which is split also into some small microplates on the edges, as most do, because of the weakness on the edge of the craton. But you also have this huge orogeny, this huge belt of lifted up, elevated land all the way from the Middle East all the way through to towards China. So this is an amazing location, but also its history is fascinating in terms of geologic time and also the tectonics. All right, so let's talk about formation. Now I've got this like originally I had this larger, wide map of Eurasia. Now we're looking at Lake Baikal in more detail and closer up. So looking at the lake, we have the lake right here. It's going to shade it in blue, so it's kind of going to stick out. Now, as you can see, it's kind of like that um, northeast, southwest kind of like alignment, and it's kind of like between two major landforms. So, in terms of not countries, we know it's in Siberia, which is part of Russia. You have this very large, elongated, use different color there, very elongated rift basin. So, to the extent rift basin. Now, the lake is part of it. It's not the whole rift basin. There's other sections of normal faulting that occur around the lake, but the lake is kind of like in the middle of this large fault. And it's stuck between the Mongol-Oshkosh belt, which is part of the Central Asian belt or orogeny, and it kind of like links up with the Burma, Tibetan, and Persian orogeny, which stems from the Indian Asian collision, that lovely continent smashing into continent situation where the Himalayas, that huge area was created, around 10 million years ago and is consistently still smashing into Eurasia today. And it's causing the Tibetan Plateau and this large, very large, long orogeny belt. And Lake Baikal is kind of like not close to it, but it's definitely connected geologically and tectonically. And we can discuss that it's between the Siberian Craton, which is very old. The southern part is between 2.1 to 1.8 billion years old, or GA, which is Giga Annum or Annum in geology speak. And most of Siberia actually dates back to about 3.2 billion years ago. So it's a very old, very stable, very strong basement rock. Now, most of it is covered in sedimentary rock. Obviously, there's some exposed outcrops of basement rock around, like in terms of different shields. But this huge platform, this elevated, around 500-meter elevated section of Siberia is very strong. And this area here, which is characterized by lots of normal faults, which we know comes from tensional stresses on the rock, and this area is shown to be weak, and it kind of like goes on the outside of the boundary of this craton, and it's smashed in between this very nice mountain belt in between, which is the Mongol Oshkosh Belt, which is a very raised, above 1,000 meters mountain range. So it's kind of like sandwiched in between these large, either belts, which just have its own system of faults because of the way it was formed, and the craton to the northwest. So that being said, there's two current theories of how Lake Baikal, what am I doing? Lake Baikal formed. So the first theory is there is domal uplift. Now there's other uplifts in the area, and this is through theories of, like, in terms of connecting this with the East African Rift Valley system, which has active rifting. Now, active rifting is defined by there's asthenospheric upwelling, there's a diapir, where there is raised temperatures, and the crustal, the lithosphere is getting thinner and being pushed away by active upwelling from the asthenosphere, or even down in the core mantle boundary. we have these magma plumes rising up underneath Eastern Africa and causing two domal uplifts, the Kenyan and East African rift domes, and causing the crust to split and therefore create the Rift Valley in terms of different branches, the eastern branch, western branch. They originally thought this was the same situation here in Lake Baikal, and that's what's causing the very deep lake, was the tensional stretching and forces pushing and obviously causing normal faults. And normal faults, actually, this fault line right here, okay, is there's two main faults that are basically hanging around Lake Baikal and causing this area of depression. And this is a half graben, so this is very consistent with what we see with depressions and basins and normal faults. Is these half gravens, but it's in the direction of east. And there's limited half grabens. There's limited other. Well, half graben means one side. So this is one-sided, kind of like depression and subsidence. So there's not a corresponding side. Maybe over in this area here is more full gravens, but the actual lake is characterized by half gravens. So there isn't much on the western side, and this is denoting that the Amur plate, which is microplate over here, and the Eurasian plate is up here. The Amur plate is moving away, and that's causing the formation of the lake. Now, this would be actively happening, and this can also be confirmed by the large and consistent earthquakes that are felt in the area right around Lake Baikal. It's one of the most active areas on the planet for earthquakes, especially large earthquakes. So we know that there is still energy in the rock, there is still movement along the fault lines, and this is causing the earthquakes to occur. Now, that's one theory. However, the second theory is that it's passive rifting as opposed to active. Now, passive means that there was rifting, obviously occurred, and that it occurred far away. So the proximity is different. Active, where you have that simple plume diapir upwelling right underneath it, causing the tensional stresses and isostatic lifting, and then obviously the depression and faulting to occur. Whereas passive rifting is that there was some sort of energy and force applied to the crust far away. In this case, would be the Indian-Asian collision, causing the orogeny, and also the fact that this platform, the Siberian platform and craton, is very stable, and the collision of India into Eurasia would cause there to be a knock-on effect, like a chain reaction, along the weaker areas of the crust between the large Eurasian and the microplate, basically ancient satur lines, which is the combination of different plates meeting, whether it's different land masses and ancient land masses connecting, and also there's a terrain here. So we know that there was ancient orogeny to form the craton originally back, in the day. So this area of weakness was kind of like forced to open up once India smashed into Eurasia, which is passive rifting. Now, various research has shown that there is not much asthenospheric upwelling. The MOHO, the divide between the lithosphere and the asthenosphere, the crust and the mantle, the MOHO is basically consistent depth across this whole area, showing no real upwelling. It's about the craton is about 45 kilometers thick. And the same thing, the Mongol Oscar Belt is a bit thicker, 45 to 50, based on the mountain range, the fold mountains, and it's pretty consistent. So there's no real sign of any kind of like domal uplift or upwelling plume as you'd see with the East African Rift Valley. So most articles are suggesting that this is the plausible reason for formations, but then it can't explain also the earthquakes. However, you can explain the lack of volcanism and magmatic material. Now, there are areas around here of volcanism, all right, and various plutonic regions around the Rift Valley, but it's smaller. It's a lot smaller than anything we find in the East African Rift Valley. So maybe this is a different formation. Maybe this is an active area for earthquakes and faults. However, it's not going to create that new ocean like Wilson cycle denotes in terms of the 4 stages. This would just be just like Lake Baikal is formed when India switched into Eurasia, and basically it's going to be more consistent. May increase in depth or width over time, but it's not like you have with the East African Rift Valley, where the Somalian plate is actively moving away and creating a new ocean in the future. So in terms of geology, you got this thin, very deep lake sandwiched in between 2 major tectonic stable regions that were created either billions of years ago by the Craton or millions of years ago, like the belt and the Central Asian orogeny, which caused by the India-Asia collision. So you do have a lot of sedimentary rock, which is actually underneath these rivers. Okay, now there are about 4 or 5 major rivers that basically add water to Lake Baikal, and there's one river that really is the main outflow. So that main river for the outflow is called the Angara. It's the outflow of the river. All right, and you've got basically the main one. There's other tributaries and major rivers that flow into this one right here. Okay, so the Uda flows into this one here, and this one is called the Selenga. And there's also a very large delta right here that goes into the kind of the central basin of the lake. And as I mentioned before, the central basin right here is the deepest part, over a mile deep. This northern basin is nothing really to write home about in terms of depth, but the southern south basin is deep, but not as deep as the central. Central is really, really deep, and it's the oldest, well, one of the oldest lakes in the world, with its own native species of flora and fauna, and is a fantastic place to study not only tectonics and geology, but also biodiversity and evolution and that kind of stuff. But the geology is also really cool because you've got a lot of old Precambrian rock right here. Okay, a lot of it is sedimentary covered, but you've got very old basement rock, and you've got strong fold mountains to the southeast, the belt, so strong fold mountains right here. Okay, and you've got high elevation. You've got high elevation mountains basically in the southeast of this map and northeast right here, and also kind of like flatter land in the Siberian Craton. But you've got sedimentary rock in certain areas of the basins, which is filled by deposits, but you've got a lot of igneous and metamorphic rock basically surrounding the whole area. So geologically, it's very old. The lake itself is between 35 to 30 million years old. And there hasn't really been much evidence to suggest that the lake has changed that much in that time. So again, it goes back to that passive rifting. But the geology is very Archean and Precambrian basement rock. You've got some sedimentary deposits around the rivers, obviously, and obviously in the basin itself, the 3 basins that make up the lake. And you've got the fold mountains and a lot of metamorphic and igneous rock in these belts, mountain belts, and also in the Siberian Craton, which makes it so strong. So this area of weakness is fascinating in terms of the lake, its depth, its history, the controversy on how it's formed. And guys, I hope you enjoyed the video. Thanks a lot.